I want to talk about some of the kind of distributed systems problems that Riak came across out there in the wild and how that's influencing what we're doing with the product now and what we intend to do with the product in the future. Riak is 10 years old this year, so it's reached its 10th birthday. Initially, I think Basho, the company behind Riak, were trying to sell a Salesforce app, and they needed a back-end for their Salesforce app, so they thought, well, we'll write our own database based on this new Dynamo paper, and they found no one interested in the Salesforce app, but everyone interested in this new database they'd written on the Dynamo paper. And so they brought a preview out, and in 2011, that went to 1.0, and then followed a period when that went into all kinds of different customers, all kinds of different environments, experiencing all kinds of different workloads, and weird things happened. Those weird things got reported back, and there was a fight to try and resolve edge cases and increase stability in the Riak product. And by 2014, there was 2.0 coming out, and 2.0 was very much about the fact that Riak KV had started as this sort of simple key value store, which put a lot of work onto the developer to actually exploit the potential power within that. So you could do all kinds of interesting things with queries, but you had to write your own query planner. You had to reason about things like eventual consistency and this kind of stuff as a developer using Riak KV. And the 2.0 release was really about trying to make things easier for the developer by providing new features that would expose power at lower cost to the developer. So that came out, and obviously the aim there was to try and broaden the scope of people that would use Riak and the people who would take it on. And unfortunately, things didn't quite work out as expected, and I won't repeat too much of what Nick said in his talk. And ultimately, sadly, in 2017, Basho went into receivership. But Bet365, who one of the biggest customers of Riak, and also the ones with the deepest pockets, very kindly bought the assets off the receiver and open sourced them so we can continue to use it today. Now, I sort of fit into this story sort of from back before 2009. I was working on a system for the National Health Service in England that was a really, really bad distributed system. It was all written by lots of different companies, all written in Java with Oracle databases, and it all went badly wrong. I was a network guy, so every problem looked like a network problem. So every problem, they got me on board. And in the end, I sort of thought, well, this is taking a lot of time, so I better learn to write applications and do distributed system myself, so I don't have these problems. So I read Joe Armstrong's book. I started learning how to write applications, and round about 2011, the contract for the original big distributed system was coming up for renewal, and by then I was working over at the National Health Service, and I said, let's start this again, and let's do it all in an entirely different way with a much smaller team and this kind of stuff. So I worked on that. We chose Riak as our back-end database. We went live in 2014. So we're now coming up for our 5th year anniversary. We've had 5 nines availability since we've gone live, with a team that's 100 for the size of the team that built the original solution. So we made quite a big difference there, and much lower running costs and that kind of stuff. Round about 2016, 2017, I was a bit knackered, and I thought, so take some time off and do a personal project. So I set myself the challenge of writing a key value store in Erlang based around the log structure merge tree pattern, which for some reason I thought would be fun. And I also thought it might be useful as an add-on in the future for Riak. And then when Basho went into receivership, the National Health Service were wondering what to do, where they should go and what direction to take. And now that I had some more experience of actually development of Riak, I agreed to come back to the National Health Service and to help them deal with Riak going forward. So that's why I'm now involved in Riak. And I've been involved in some of these releases that have come on. You'll have to excuse the numbering, the logic I'll explain over a beer. But we had released 2.2.6, which was came out in 2018, and that really combined what was the old enterprise features and the old open source features, and gave some very simple enhancements that had quite big wins for us, particularly in the National Health Service. We today have announced the release of 2.9.0, and the key thing that comes in 2.9.0 is that backend that I'd written as a little project back then, and that I talked about at CodeBeam 2017 and the improvements that came with that. And then we're concurrently working on 2.9.1, which brings together a lot of the features that I talked about last year at CodeBeam, which is a new way of doing active anti-entropy. And we're also concurrently at the moment, we had a workshop just last week working on the FreeDough release of Riak, which is where we moved to OTP 20 and rebar free. So we've got lots of releases going on at the moment, though it does take us quite a lot of time to go from ideas through to releases. So though we had kind of working code back in 2017, when I came to present then, it's taken 2 years to bring that through to a full release. So Riak key value store, Basho went bust, and there were lots of kind of business reasons why that went bust, and you can read the court papers of the people who are now recognised in US case law of being incompetent and unqualified that were running the Basho company back at the time. But also, if the product was amazing, mass adoption would have happened anyway. So why didn't mass adoption happen? It can't just be because of business failures. And the reality is to a certain extent, Riak was a bit off trend for its time. So, yes, it was there in this wave of NoSQL that was coming along and this kind of stuff. But also at the same time, a lot of businesses that were setting the trend were very much focused on speed to market being everything. If you're Netflix back then, there's only going to be one dominant supplier of TV programs around the world. So, don't wait around by trying to make something that's perfect. You need to get something out to the market, straight away. You've got to get features out there straight away. And Riak was stuff whereby it was kind to your operators, but relatively unkind to your developers. It made your developers work, it made your developers think. And if your developers have got to work and think, they're going to be slower to market. The other thing as well is that in order to use Riak effectively, it made no sense unless you're going to have at least 5 nodes in your key value store. And these days, one machine is fairly powerful. So that actually wipes out quite a lot of use cases. And a lot of people starting at fairly low levels, it made no sense if you had to start with 5 nodes. And obviously now going forward, a lot of people that have a problem that needs multiple machines will look to a service rather than to running multiple machines. And then also, I think Basho found is that when you, in order to become successful as business, you don't just have to, get people who want to use the open source product in kind of trendy places to use your product. You have to get enterprises to buy it. And enterprises kind of have funny things that drive their purchasing decisions. And in particularly, they like things they can measure at pre-sales. And with a database, all you can really measure at pre-sales is performance, and Riak, it's going to want to persist things into many locations. It wants to send things over to the network, and so it's not going to win over, in a benchmark test against a pure memory database that might sort of lose a bit of data eventually. So, it loses out in measures, and also, most enterprises tend to get obsessed with the things they don't need at the moment, but they think that they might need in the future. Oh, yeah, we might need a time series database, or we might need, 500 nodes in the cluster. Can you tell us if you can do that now? And I think that helped them. That hindered Riak in terms of enterprise sales. So, kind of that's where it didn't fit in, and in reality. Riak does have a nice little niche though, and particularly where its niche is where you've got a database requirement that can be satisfied by a relatively simple key value store, but where the availability and durability guarantees are non-negotiable. Yeah. So for things like the National Health Service, we're used, the spine service that's built on Riak is used by so many different applications out there that have so many different levels of critical importance, so many processes are dependent on it. We don't actually know what would happen if it failed, so we really don't want to find that out. So availability is absolutely critical, and at the same time durability is really important, because like losing data has, you know, political consequences as well as real and potential clinical consequences. So where availability and durability are non-negotiable, Riak is very key for that niche. And the other thing about Riak is that the guarantees that it makes about replicating data and this kind of stuff, it keeps those guarantees constant through failure. So on other stores, you know, if you guarantee that it's going to go to 3 places, under failure it might only go to 2 places. Riak, it still goes to 3 places. And the big difference that makes, it means that your operators can eventually react to problems. So, you know, if you're running a degraded service on failure, you need to rush out fairly quickly to go and replace hardware and this kind of stuff. But actually, if the service still runs fine on failure, you can take your time over that. And that actually made a huge difference for us, because our biggest cost saving we made in terms of the IT infrastructure we were building was actually reducing maintenance contracts, getting rid of 4-hour fixes and all this kind of stuff, because we could fix, you know, if a node failed, we could take 2 or 3 days to go around it, to get around to fixing it without worrying about breaching our availability guarantees. It is not the fastest of databases, so latency has to be acceptable. You know, so you know, if you want something that's going to guarantee you a response time in 200 microseconds, you know, sort of sub-millisecond latency, then you know, then Riak's probably not the database for you. But generally speaking, with Riak, we try and make latency predictable. So although latency exists, it should exist in a fairly predictable way no matter what's happening to the database store. And then the other thing as well is that there are very few operational processes that surround a Riak database. So if you want to have very small decision trees for your operations staff, if you want to have very few procedures to rehearse and learn, and then Riak's very good for that. You know, it needs to be of a certain scale, but at the moment, you know, it's not tested much beyond, beyond 100 nodes. So if you're at, you know, Google scale, then you probably need to have your own database and not a Riak database. So a little bit, some sort of brief stories about what's happened with Riak when it went out there into the real world, and what problems did it come across, and then how are we changing the product to deal with those problems. So one of the things that Riak tries to guarantee is that, you know, we always keep your data. So we've got many clients potentially sending changes into many nodes across many clusters. So eventually we're going to get conflicts between those items of data, and when we get conflicts is we keep siblings, so we keep both copies of the data. And then that's one of the things the developers have to think about. They've got to think about how they resolve those siblings. But the key thing is the database won't lose that data for you. So that was a nice safety guarantee. However, sometimes clients aren't perfectly behaved. Sometimes they aren't well behaved at all. And it's not just clients doing puts into the store. All the time, we're trying to self-repair within the store. If we discover discrepancies on a read, if we discover one node's behind, if we've got an anti-entropy process that discovers things behind, and we're trying to resolve those discrepancies, that involves new puts. So we've got the database doing puts, we've got clients doing puts, we've got sometimes clients doing bad puts. All this is happening across multiple nodes, across multiple clusters. And what actually could occur is that a single object could start growing the number of siblings it had, yeah? And all those siblings are stored together under the same object in the back-end data, in the back-end store, and they're all sent over the wire when they're requested. And this explosion of siblings could actually cause a couple of problems. Number one, it could cause instability in your database with head-of-line blocking issues, and also with timeouts on your back ends, and it actually could cause unavailability of all of the data within that object, of all of the siblings, because actually the siblings could get so many and the total size of the object so much that they could no longer be extracted. So sibling explosion was probably the biggest and worst bug that occurred in the early days of Riak. And this problem was resolved by changing the way that causality was tracked, so we could get better at discovering that actually this client has done the update, has already seen some of those siblings, and therefore we know that client is happy for those siblings to go and be replaced by this new object. And so that involved a change of how we were tracking causality through version vectors that went in, I think, in the 2.0 release of Riak. But then that itself caused some more problems. Because now we'll be potentially more aggressive at pruning siblings, and the theory behind these version vectors assumed that an actor in this process would never forget that it's seen some information in the past. Yeah, but in the real world, disks get corrupt, database backends get corrupt, this kind of stuff, and we can forget something that we've seen in the past, and then we may, if we've forgotten something we've seen in the past, we may send a new update that looks like an old update that other nodes can then might then discard, and we might then lose data that way. So that caused another set of problems that had to be resolved in the 2.0 cycle. And then there's further problems as well caused by deletes. So if we have an object and then we want to delete that object, what happens then if we want to create a new object over the top of the deleted object? How do we tell the difference between an object missing and an original object there? How do we tell when actually the missing's the correct, and so we need to get rid of the old object that's been replaced by the delete, or when the object's correct and has actually overwritten the delete? And so that's causes lots of other issues and lots of other things that have to be resolved in Riak. And so there's various changes that have gone into the 2.0 cycle under Basho to try and refine the solution so we don't get these problems. Aggressive recovery. So when we fail a node, we eventually want to recover the node. And when we recover a node, we want that node to discover all the data that it's got missing. And in early releases of Riak, that recovery process could occur, but we don't, Basho didn't know what hardware people were going to run on and this kind of stuff. So how aggressively can we recover that data? How aggressively can we send it back? And in some circumstances, what was discovered is that it could be sent back too aggressively. So you recover a node, it starts receiving receiving data back, but that data is all getting transferred too quickly, and now the node goes back down again. The nodes that are sending that data start getting into trouble. The whole cluster starts getting impacted by the recovery process. And we have lots of recovery process to make sure that we always push out all those data to all the places it needs to be, lots of anti-entropy processes, lots of handoff processes. And so over time, there's been a need to build lots of throttling into the database and with configurability around that throttling and some basically distributed lock mechanisms so we make sure that there's not too much concurrency of this activity going on. So over-aggressive recovery was a key problem. And then, weird things happen in the real world of networks. So I'd come into this thinking that, every problem that you say is a network problem. It's not really a network problem, it's an application fault. But, networks are weird too, I'm afraid, as we discovered. So there's this problem called TCP Incas. So in Riak, when we try and get an object, and the node that receives the GET request goes to the free places that have the object and asks for them all to reply. Now, if your cluster's not under heavy load, it's likely that all those free places will reply almost at the same time. Yeah, and when they reply almost at the same time, the cumulative size of all those replies might be bigger than the buffer on the interface of your switch. And if it's bigger than the buffer on the interface of the switch, it will silently drop packets off that. And because it's silently dropped packets, your connections within Erlang, your end connections that are interconnecting all your nodes will go into TCP backoff, and you'll get reduced capacity until it can ramp up again. And so what was seen then when we had when Basho had a customer with very large objects, this TCP Incas would happen frequently. And this is a key problem, because the only real way of resolving it is to have bigger buffers in your switches. And if you know anything about the economics of switch manufacturers, that costs you a lot of money. That's a disproportionate amount to the amount of memory required to actually hold the buffer itself. So you can end up paying 4 or 5 times as much for a switch just to get a doubling in size of the buffer, even though the actual cost of that memory may be marginal compared to the original cost of the switch. So in the Basho days, there were some advantages that Basho had. And they were able to discover some of these problems through developer reasoning. So they had a team of probably 20, 25, 30 engineers, and the excellence of that team, I think, was first class. And they were able, although they were all remotely distributed, they were able to discuss matters between them. They were able to reason about these things, and actually discovered some of these problems. So some of the data loss issues around the sibling resolution and this kind of stuff were all discovered through developer reasoning. Yeah, and so Basho had the capacity to do that, and they obviously discovered problems through testing, and they used different forms of testing. Basho had their own test framework called Riak test, and then they also used property-based testing. And they also discovered problems because they happened in the wild, unfortunately. But if you're one central organization, all customers report back to you because they all want to kick you and complain, and they tell you straight away then something's gone wrong, and you can go and reason about that, and then put the fix out and make sure that other customers don't suffer from that. So now where we have no Basho, we simply have people at customers that are trying to develop Riak going forward. It does mean that from a problem perspective, to a certain extent, we have better time allocation, because we're not under any pressure to do features. We know the priority is to keep the thing stable, but we have reduced capacity to reason, and we have reduced access to information, because some customers have hired ex-Basho developers, but they put a wall around them, they keep the information entirely within their organization and this kind of stuff, and we just don't have as many people working on it right now. So we have a real issue going forward with these kind of problems that can occur in distributed systems. So we have to evolve to try and do that. And so the first thing we had to do, we have to make sure we've got good discipline around test and around dialyzer. And a big part of the 2.2.6 release was just about making sure that the test did pass reliably. One of the big changes we're now making going forward is that we realize that it's not enough for organizations like the NHS and Bet365 to actually employ people to develop the product. If it's going to be used by other customers, those other customers deserve some independent assurance of that by people who have their own reputation to protect, and people with real experience of testing services. So from the NHS perspective, we've now turned to Quivic, and all the stuff that we do is we hire Quivic to then go as a service provide testing, mainly through property-based testing, and assurance of what we do. And then the other thing that we're going to try to do going forward is kind of avoid low reward improvements. So you can kind of look through the Riak code and kind of say, oh, well, I could modify that, and that would give me a couple of percentage points, and I could modify that, and that would make that a couple of milliseconds faster. And generally speaking, we're going to try avoid doing that, because we don't have the capacity to reason about the consequences. But in fact, we can probably get most of the improvements that we need simply by getting on track with OTP. So Riak currently runs on R16 OTP version, and if we actually get up to pace with OTP, we'll start getting the sort of improvements that we might get from functional changes just off the back of the platform. So we found in moving to OTP 20, we get some immediate performance improvements. If we go to OTP 21, we get improvements, hopefully because of file I/O changes. In the future, we'll get improvements because of the sort of link fragmentation interleaving to deal with head-of-line blocking. So actually, in terms of improving the performance going ahead of Riak, we should stand on the shoulder of the OTP team and try and get up to pace with the OTP team, rather than try to fiddle with the Riak code itself. So some of the changes we've made recently in Riak 2.2.6. We made some basic fixes to cluster claim, which had kind of been known as being broken for a while. And we did a thing called node confirms, which is just a different way of telling Riak, for your application to tell Riak, I definitely want something to be persisted to 2 different physical devices before you say OK to this. And it's a lower cost way of doing that than Riak had previously had to use this parameter pw equals 2. But for Riak 3.0 and beyond, we're going to do a lot more stuff around getting rid of R16, moving on to version 20 and beyond, and also trying to get rid of non-Erlang code, because the non-Erlang code is harder for us to test. It's harder for us to reason about. It causes us to, have to take one sort of code head off and put another code head on. And so the more we can get rid of that, the better. We just got Erlang running, so Riak running on OTP 20 last week. So we did a volume test, and as I mentioned earlier, the key thing that we're focused on with latency is not median latency, but it's high percentile latency. So this is looking at the high percentile latency of our index queries. And the blue line is the high percentile latency of where we were in the current release, today's release 2.9. And just by taking that same release, making it OTP 20 compatible and running on OTP 20, that high percentile latency drops down to the red line. So we can make dramatic improvements just by doing that. And historically in Basho, the NHS as a customer is very concerned about this metric, and we got them to make loads and loads of changes to their C++ back end to try and improve the performance of that. And there were lots of risks and lots of problems that came off the back of those changes. And actually, we're better off getting those kind of improvements through OTP improvements rather than trying to make them ourselves going forward. One other problem that's a key one and has been an ongoing and an onerous issue in Riak is that Riak performs very well when a node fails. Yeah. So if a node fails, you pretty much get the same throughput in the cluster than you would have done before the node fails, which is one of the reasons why we can relax and chill out when a node fails and take a couple of days to go around fixing it. However, a slow node is a different matter. And the slow node is a different matter, is that we always send our work, our GET request in particular, to 3 different nodes. Now, if one of those is slow to response, well, that's just like a failed node. The application can keep moving forward, but it's still receiving its full workload of requests. Yeah, and eventually its queue is going to start backing up. And eventually we're going to need to talk to that vnode. We're going to need to talk to it to coordinate a put. We're going to need to talk to it to do an index query. And when we need to talk to it, we've got to wait for that queue to drain. And that whole promise of predictable latency goes out the window at that stage with one slow node. And there are lots of things that can cause one slow node. One of the big things is background jobs. So anything that we're doing, around anti-entropy or this kind of stuff, or handoff, to try and maintain the durability guarantee within Riak, is potentially going to create some background work, and that might, if that's focused on one node, that might cause that node to go slow. We can have hardware failures, so if just one disk fails in a RAID array, we can get hotkeys. These kind of things can all cause slow nodes, and that's a much bigger problem for us than a failed node. So one of the big focus for today's release for Riak 2.9.0 is that we're trying to address that problem of a slow node. And there's 2 ways in which we're addressing it. The way you tend to first find the problem of a slow node is when that slow node, the V node on that slow node gets chosen as a put coordinator. So we've added in a bit of polling to make sure that we don't choose put coordinators that have big queues. And just making that change gave us a step change in high percentile latency of puts. And then the other thing is that what we realized is that we're constantly, when we're doing gets, we're sending free gets out and getting free responses of the full object back. But actually, we're going to discard 2 of those responses most of the time, because most of the time we're going to discover that all free responses are the same. Okay, but when we're trying to track causality to deal with siblings and eventual consistency, we've got this thing called the vector clock on the object, and the vector clock's the only thing we need to know to find out whether objects are the same. So actually, we don't need to get free objects, we only need to get free vector clocks to determine that all the V nodes are in sync. And when we've got those free vector clocks, we can go to one of those nodes to actually get the object from, and we can actually choose the one that responded fastest to the head request. And if we do that, that means that it's only the fastest nodes in the cluster that are getting our get workload. So if we have one slow node, that will start responding slow to head requests, and then it will stop getting get requests. And gets are much more expensive to fulfill than the head requests. The head request being a request just for the metadata that includes the vector clock. And so what actually will happen is that work will start naturally distributing around the cluster. And so what we're seeing with this is that just in normal operation, by switching the NHS workload from Riak sort of 2.2 with the level DB backend to Riak 2.9 with the level ed backend, we get about 50% improvement in throughput, and that just comes from replacing heads with gets. But the big thing and the most important thing for us is we're seeing order of magnitude improvements in high percentile latencies. So in 2i queries, because 2i queries have to go to a coverage set of vnodes, and they'll be as slow as the slowest vnode that you go to, and because of the puts where it gets chosen as a coordinator. So we're actually seeing quite radical reductions in that, and we can now deal with one slow node without actually breaking our promises around predictable latency. The other big issue is reconciliation. So we have lots of data in Riak clusters. The biggest customers have petabytes of data in their clusters. And because we asynchronously replicate it everywhere, we can't, and the message isn't reliable, we can't be sure that all our data has got to every place that it needs to get to. Yeah. So how do we resolve that problem? You've got to have a way of checking that data between 2 different clusters is equivalent. The data sets are equivalent, and the data between different nodes or vnodes that should have the same data are equivalent. And there's a simple way of doing that, which is to walk over every key one by one and checking that the object's the same. But that's really, really expensive. And when we're walking all over the objects on one particular vnode, we're going to cause a slow node again and that kind of stuff. So reconciliation is a problem for us. So how do we actually reconcile those clusters without creating a huge amount of load? And what we actually found in the NHS when we first went live with Riak is that the majority of the hardware resource on the cluster was actually spent on reconciliation with the key listing for full sync, and eventually we just had to turn it off to get rid of that problem. I talked about this last year, so I'll only cover it very, very briefly now. But we've come up with a new way of doing active anti-entropy based around Merkle trees, which already existed in Riak, but we create the Merkle trees in a different way to make them mergeable, and this has had some positive consequences for us. Firstly, we can merge together the trees across different vnodes, so we can provide a tree that represents the whole cluster. So we can compare trees between clusters where the data has been distributed differently. So we might have one cluster that has a ring size of 128, and the data is replicated 3 times across that ring. Might have another cluster that has a ring size of 8, and it's only replicated once, and we can actually compare those 2 clusters, and we can do it really fast. And then the other thing that we've added is that we discovered that we could build into the store that we use for AntiEntropy some acceleration and some hints around the last modified date of the data within that store and where data of different last modified dates are kept. So we can very quickly build up dynamic anti-entropy trees, not based on cache trees, by rolling over the data for stuff that was recently changed. So we can very quickly say, here's an anti-entropy tree to represent all the data I've received in the last hour. Yeah, and that allows us to do comparisons, not just on all the data in the cluster, but immediate comparisons that we can decide on the fly. So we might want to say, right now, I'm interested in this bucket and key range. What are the changes received in the last hour? 2 clusters, compare and repair those differences. And we're also, as part of that, simplifying and fixing real-time replication. So that's the big feature of 2.9.1 is making that available for intercluster anti-entropy. So developer productivity, I mentioned before, your React gives hard problems for developers. Think about eventual consistency, potentially write your own query plan and this kind of stuff. And in 2.0, going way back then, there were various things that were put together by Basho to try and address this. So there's integration with Solr. So, because on the basis that people would find it easier to query in Solr rather than writing their own query planning engine. These things called conflict-free replicated data types, so you didn't have to think about how to resolve siblings. The database could merge those siblings for you. There was a strong consistency feature so that if you had some particular subsets of your data where consistency was really important, you didn't have to go and get a second database to put those things in. You could use the strong consistency bucket for that. And then there was some MapReduce features as well, available both in Erlang and JavaScript. So yeah, I'll go on. So that's the sort of developer productivity features that were there. There are also some operator productivity problems. So if you run a React database, there's some things you expect a database to help you with, and React doesn't really help you with. So if you ask Riak, how many objects are in the database, its answer is, oh, you tell me, you put them in there. Yeah, it doesn't give you answers to those kind of queries, and there really was never a way of backing up a database. The answer is, well, it's replicated to 3 places, to multiple clusters. Do you really need extra copies of all of that? And we're worried about what would happen if we rolled out a bad application change and we started corrupting all our data. So we needed some solutions to operate the productivity problems. So for FreeDough, one of the things we thought about originally is that these developer productivity features that we got, many of them were frustratingly incomplete. Yeah, so we've got Solr integration, but that kind of has an impact on the other promises that we make about Riak around some of the things around the stability of the service, because you've got to load a JVM onto every box and all this kind of stuff, and Solr may take a load of your resource that you wouldn't otherwise for Riak. You're more likely to have hotspots with queries that then cause slow nodes and that kind of thing. Conflict-free replicated data types worked fine if you kept your objects small, but you can't guarantee that your sets are going to stay small, and it didn't deal with big sets. Strong consistency worked, but not when combined with other features, and there were a few gaps in the testing of that. MapReduce was very good if you wanted to give up all the resource in your cluster to resolve your MapReduce query. But what happens if you want the MapReduce query to run in the background, because what you really care about is your gets and puts, that is your day-to-day business? There was nothing really for helping with that. So originally for 3.0, we did consider whether we should just actually retire some of these features on the basis that we would rather focus on the key promises of Riak, and actually that was a better and more stable way forward than trying to maintain and improve developer productivity. And And what we actually found, though, when we talked about retiring these things, even when we talked about retiring things that we thought no one used, we discovered that some people used them, they were important to people, no one wanted them retired, so we've had to roll back from that. We may end up in the future with a kind of nucleus React product there's a React without these additional features, so that if you don't want to run with them, you don't have to actually kind of install them and deploy them. But yeah, those things aren't going away. And really, they need to be enhanced. They need the problems resolved in them. We need things like, big sets, which has been talked about as a feature as well. We need more work on the React Solr integration. Perhaps we need integration into other query engines like Elasticsearch and this kind of stuff. However, there's a bit of a funding shortfall for those things because, generally speaking, the customers that are funding React development at the moment are the ones that are focused on the features that are already there and present in the kind of nucleus of Riak. And then from the operator perspective, we have actually done things. So we've introduced operator queries in 2.9.0, so you can now ask React questions like, tell me how many objects you've got, tell me what your average object size is, tell me how many objects over 1 megabyte that you've received in the last hour, tell me what keys are currently in a sibling state. So lots of things that React couldn't previously tell you, it can now tell you. And we've also got an answer, depending on your backend, onto how to do hot backups. And they are, particularly with the level-ed backend, they can be done with low write amplification. So it works very well with rsync. So that's kind of where we got to now, where we've got the 2.9.0 release out, 2.9.1 pending, we've got FreeDough coming with OTP 20. We want to keep pace with OTP releases going forward from there. So does React still have a future? Well, obviously some customers went away when Basho went away. Some customers were very concerned about risk management without there being an organization to blame. Other customers have quite enjoyed Basho going away in the sense that they've enjoyed the power of control and the ability to finance that power of control by not having to pay licenses anymore. That's kind of gone two ways. Obviously, in the interim period, I think the uncertainty was very troubling for almost everyone. Certainly, it was troubling within the NHS. I was very pleased with the maturity of the National Health Service as an organisation, as a big public sector organisation, that it was still prepared to carry on with an open source project after the death of its vendor, so some people have been able to deal with the uncertainty, but hopefully we can bring more certainty now going forward. One of the issues that we got is that we are producing releases, but we're not producing releases in a timely manner. And the reality is we just don't have enough bandwidth, and too many of the people that we depend on to get things done have day jobs, and day jobs push things out the mark in terms of releases. But we do see signs of improvement. We're seeing increases in contributors. We're seeing work on concurrent releases. So I do have real hope that Riak has an ongoing future, and I do think that that original Basho engineering team did really, really important work, and I think it is good that will be preserved, and also that Riak will be there for future work within academics and this kind of stuff to improve and move that forward. And I know as NHS as a customer, ultimately when we sat down and talked about it, is that we knew we could move to another database, but the reality is we found it really hard to find another database that gave us that combination of durability and availability guarantee, and deep down we didn't want to move. We were happy with Riak, and so it's important for us that it's staying around. So that's my bit. Thank you.
Okay, so in a universe where you had unlimited funding opportunities and stuff, is there anything that you've seen over the last 2 days which you think would be particularly interesting or relevant to the project going forward?
The most interesting stuff is the stuff we should get for free from OTP. I'm very interested in the improvements that are coming along there. There was a very interesting talk earlier from Pierre about actually expanding out clusters and the intercluster stuff, because that was always a bottleneck for what the size of your React cluster could be, the complexity of all the connections. So I think that would be very interesting, because that would allow React to be used in those kind of 1,000 node plus cases. So that's really good. And I do think probably if we had more funding, of those developer productivity features, the one that we'd most like to work on is the CRDTs and further improve those. And I also think probably as much as development, probably what we need is support for developers, in how to exploit Riak and how to use it. Right now, there's a hodgepodge of sites, some of them branded Basho, some of them not branded Basho. A lot of them with confusing advice. A lot of stuff kind of was deprecated and not deprecated and this kind of stuff. And there's no real Riak cookbook to go and say, you can do these actual really powerful and interesting things with Riak, but this is how you do them. And so I think there's lots of people repeating mistakes, and there's a lot of people not failing to exploit the full advantage of Riak. So as much as features, I think if we had funding, we could probably do with working on documentation and engagement with the potential users.
In the more common sense, where you don't have a heavy load, do you have any measurement of the fact that you need to do 2 round times, first one head and then one get?
Yeah, so it does have an effect on median latency by an extra network round hop. Currently, we're waiting for 2 responses so our responses before we go and get the get. It may well be that we can do the get immediately after the first response, and generally speaking, because that first response is probably going to be from a local node, the additional round trip becomes negligible. But we do see a measurable impact of 2 or 3 milliseconds on the median latency from that. And again, it's all about trade-offs. And for us, we think the tail latency is more important than the median latency. And if the median latency was everything, you'd probably be with another database.
We had a look at the Riak repos, and we noticed there's quite a few which are there's a number of repositories which, we don't know which one is the main one. And the NHS maintaining their own, Bit365 doing their own thing, which is the reliable one?
Yeah, so the canonical repos are still the Basho ones.
Okay.
Yeah, and obviously it's a shame that they're still branded Basho.
Yeah.
But when we cut a release, it goes onto the Basho repos.
Okay.
There are some issues that the primary branch that comes up is the develop branch, which in effect is an abandoned branch from our perspective now, because the release is cut from earlier. So there's some housekeeping that needs doing around there. Okay. There's a lot of repos within that Basho thing that they're being forked, where actually we should be going back and using the genuine source, so things like Web Machine and Mochi Web going forward. Okay. And I think we'll start doing that as part of the 3.0 release to do that.